started. Go ahead.
Okay, can you hear me?
Yes.
Okay. Hi, everybody. My name is Boris. I am co-founder of GetArchive. This is a small company. We only have about 5 people. But what we did, we built a search engine which competes with image search of big guys. Uh, we focused on public domain media because there is no copyright issues, and there is a need for those public domain media from people who do everything creative, videos, books, documentaries, stuff like that. So we started with collecting public domain images from hundreds of sources and created a repository, Picryl.com, and immediately faced problem because we collect metadata from different sources, different languages, different quality. Some images actually got found, some images not, if you use standard uh, search mechanism. We use, uh, we use MongoDB as a database with Elasticsearch connected. Elasticsearch is tuned to be fuzzy, meaning that every search request multiplied by all kind of misspells, but still it didn't work well, especially with multi-language metadata. So what we did shortly after we launched, we started to use early version basically of the GPT-like network. Google AI created multilingual semantic search. They put it into non-copyright MIT license, so we could grab it and use it. And what it is, it's a machine learning network which is taught on a pairs of the text from different languages, so it can recognize patterns in the text. Sometimes it's worked very well, sometimes it's not. For the content that is popular, in our case, if it's famous artists like Rubens, it works very well, and it finds Dürer with special characters, you and without. But for many sorts of metadata, less known, less popular, it just doesn't work. So we combined it with normal search and use it as a fallback for the textual uh, entry. So if Elasticsearch finds a lot, we don't even launch semantic search. If normal search, old-fashioned, even with all the fuzziness, finds not too much, we use semantic search as a fallback. I will demonstrate it later. Then in next year, we had to improve it even more because still lots of images couldn't be found because they simply didn't have enough metadata uh, for very uh, for very same metadata on thousands of images. And if you look at any large source like Library of Congress or National Archives, you'll surprisingly find that you have hundreds of thousands of images that are having exactly same metadata, exactly same tags, descriptions, titles, stuff like that. So it's completely impossible to sort them. So we started to use OpenAI Fleet when it went open source. Usually the stuff goes open source when they got new version, like now they have Click 2. And we did the same. This is while Google semantic search is CPU based, Flip is GPU. So we had to run all our image based through large machine. It took us months, but we did it. What we got is vector for each image with probability of certain labels calculated. The label set was provided by us, and this is quite good because we use the label set that we created ourselves, which is basically relevant to the stuff that we have art, old images mostly, a little bit of stock images, but mostly it's historical stuff. So we fit all kinds of the labels related to history, such as Napoleonic Wars, World War II, and all kinds of physical objects that might not even exist today, like steam engines, stuff like that. And actually, in 2022, at very late, we looked at Bleep. It wasn't in open source yet, but recently it went to open source. Bleep is basically another network, which is model, which differs from Flip. The difference is that Flip basically gives you back whatever you gives to Flip. If you give label, it gives label. If you give sentence, it gives you sentence with probability, which we didn't do because sentences are not so probable as just labels like single words or some entities like black and white or old photograph. With Bleep, with the second one, we don't have to give it anything. It just produces sentence-like description, which is semantically look like normal human expression. And this is very good because we can actually feed our semantic search with leaps out. So the whole idea of this is to use different models, which are free to use, to improve metadata in every image object. We have 26 million of them, actually more, but not all of them are in public access. And just augment whatever metadata they have. They come with metadata that we capable to generate. So shortly about our stack again, we have a couple of machines. We have two networks. We have Google AI old stuff, which is like vintage, but we can't find anything new in this field. Somebody knows, please let me know. So here is the difference. Old school search was basically tag based or very short text segment based. And if we look at our database, we have about uh, about 1,000 results. That Elasticsearch with fuzzy extension is capable to find. With Elasticsearch and Google AI as a fallback, we can find 10 times more, however, with high amount of false positive results. But anyway, for someone who is looking for something really rare, that's better user experience than just one case. And also, it can retrieve in multilingual metadata, different Russian and Japanese and Turkish, and it gives you back metadata that it counts with very little variation. Actually, when you type in English, it's better because it maybe have English content, so we give some adjustments to produce maximum search results for any. But basically, it's language agnostic. You can put whatever you want, and even gibberish, and it returns something. I will demonstrate how it. So the next step was in 2021, before Leap and GPT disappeared. We did all school. We tried to create our data sets, which we created about 800 before we stopped because we years. But we still have around 800 supervised data sets. Some of them are really big. How we made them big? We made a small data set of about 1, 2K images based on human tags and metadata. We supervised it, so we cleaned up all the noise. And then we get a network and we ran everything else that we have against it. So we have data sets. Some of them are really huge. For steam locomotives, for instance, we have about 36,000 of them, which is really great because if you look at the big locomotives, not small ones, the total amount of large locomotives that was used on the railways with a bunch of cars never produced was about 50,000. So we probably have about significant, maybe 20% of all locomotives ever existed and built by human beings. Here is some comparison between old school Google Vision and that vision. It's a little bit different. Yes, it's in blue. The Google Vision has two flavors. One is just uh, label-based vision, which is much better than ours because I estimate that it's about from 20 to 50,000 labels there, comparing to hundreds of ours. And it's even better than our clip version because we only fed clip with limited amount of, of labels, just a little bit less than 10,000 for the reasons of economy, because the more labels you feed, the longer it takes to run the picture. And it was just found by us that if we feed about 5,000-6,000 per image set, then we have a reasonable time and we can get all our 25 million images through. And in a couple runs, we got what we see here, which doesn't really look much worse than Google's. This is an amazing result because Google spent lots of money, lots of workforce to get what they got, and they got even web division, which is basically what Google knows about this page and image on it. They provided for free, not much, but still. And we were able to basically recreate very similar result with just a little bit more approach. As you can see, we have all our labels with predictability, so we have vector. And using this vector, we do similarity. We build pairs. So each image has its own similar images. So we built a couple of flavors of the similar images. I will demonstrate it later. For each image, we have three sets of similar ones based on a different method. So to get things short, summarizing, we use Google semantic search as aid to search, which is an ability to search in multilingual database and even search for something that would be found, but it produced noise. We fed clip with custom classes relevant to what we have, and basically we can repeat it, and whatever custom classes we feed, the result will be different. So basically, if we had the customer who is only willing to see certain things in images and image sets that are reasonably relevant, I don't know, like outer parts or stuff like that, we would be able, to some extent, to use clip to generate those labels. We use clip to build visual similar, and we combined human metadata clip and clip to improve our what we are thinking about doing next. We are thinking about getting textual output in the form of sentence with specific clip based labels. So instead of a generic outputs that the current open AI given, which is 2.1, which is not open source, which is state of the art, which is never released yet. We would try to generate something that would be generated by the real person who is interested in classification of the French art of 18th century, stuff like this. So instead of painting of a woman, looking left or right, we would have Marie Antoinette of Austria, Queen of France, Benedict, and some other much more useful method. That's not ready yet. I don't know when we reach to that. There are several approaches. One was just replacing similar classes in sentence with similar classes and labels. Like if we have woman and we have Marie Antoinette, we can that it's woman who's Marie Antoinette, but it will produce a bunch of grammatic or poorly written phrases where lots of stuff is missing. So probably we might use something open source again. Just a couple of days ago, the Dolly 2.0, which is basically chat GPT like GPT, was released like previous GPT, not 4, 5, 3, but it's good enough for us and would allow us to feed it with human data, sleep and belief, and get something, I hope, much more useful than just a woman in a head looking um, every uh, slideshow, and I can switch to demonstrating the product itself. Are you with me, guys?
Yeah, we can
I
see it,
will.
but
Okay,
please
good.
talk louder.
Okay, I will. So now first, let's go to something like data set 1920s cars. So we have a data set of 5,000 images, which is supervised. So it's very low noise, and it can be used for anything. Now you click on one image, you have a very cute picture, reason, and you have similar sets. This is vector set. So Click found something that is relevant to this image, and it worked pretty good. It is not fed with any specific information, just fed with image itself, and it works amazing. And this is the first similarity section, which is visually similar, but not in pixels, but vector similar. The second one is related. This is just this title sent to semantic search, and images that have similar title are retrieved. So if you look at this Robert French, motor car at large, should be similar. Robert Lullier, Robert French, Robert Lansing, Secretary of State Robert Lansing, and so on. So it's semantically similar, and it is very funny because if you just replace 1920 cars without tag, now you're gonna get both Elasticsearch and semantic search, and you can see that suddenly we have 16,000 now, not just 3,000 that was meticulously tagged, and they rank it differently. And we didn't do much to rank them. It ranks itself. And we have 161 pages of this. Probably towards the end, it is less and less, not probably, actually, less and less relevant. But now I can show you how fallback works. You just type some gibberish here, and you can still find something. It's going to be even same amount or even more. But why the gibberish is here? Probably we need just remove cars and we gibberish only in 1920s. So why we have it? It founds this Scandinavian. So it founds Lens Museet, Galgeborg, Sweden. Or if we even remove 1920 and do only gibberish, it just finds something with gibberish type, which looks similar. Like let's do number one here. Yeah, here we go. This looks similar to this. So if we replace it with something like Ryu, it will probably find some here. Let's check. Some Hebrew, but let's do just FP. Okay, it should be something different. Okay, let's skip it. So what else? What I want to show? Basically it, and I'm ready for questions. Well,
So why would people come to your website?
people can go to Google and look at Google for 1920 cars. And what they get if they're smart is that they need to click images first. Then, if they want to use any of those images, they might know that there is a selection of the usage rights. Then only what they have is Creative Commons licenses, which includes both public domain and Creative Commons that basically generally requires backlink and cannot be really used as they wish. So what we have here, let's do it. It's actually actually cars, and nobody really knows what is the license. For some of them, you need to pay money. Some of them can be used freely, but nobody really told you whether or not this. Yeah, there's always a danger if you misuse it, or can be fined for something. So if you choose 1920 cars with the extension Creative Commons, you have Picryl, LOC. This is another domain of ours. This is another domain of ours. That's basically how they come from Google, and why they come. They want clear right. They want use when they come. When they come, they see that to use bunch of disclosures. Then they pass. Basically, this is
I have a few questions. I think it's a great website. It's a very convenient, I believe, and there is a more user friendly. To me, it's like user. It's more. There is some explanation. It's easier to navigate. So personally, I think it's a more user friendly, I would say. I have a question. Do you specialize in specific image searches? For example, history, cars, or art, for example. Do you have this type of search categories, search specialization?
Okay. What we have is collections. That's what our staff likes to do. So I like to like the trials, and I have worker art, and we create collections that you found through Google. And also here you can see what people actually download, because those are popular tags, meaning the message of images with the tag that Yeah,
So it's a
that's
category
that's
you're saying, right? This one, this tags, it's a category. I can.
it's actually in the massive of tags that is tagged posters. So if you click on it,
Mhm.
you can see posters, which is very convenient, 58,000 of them.
Right.
And then if you look at those and you only want art posters, you click this,
So you have a
and it
filter
will
actually.
go, yes, but we have much more, but we usually put on front end what is easy to use on mobile and that. So if you just click propaganda, it will switch to propaganda. But we can actually apply both. We can apply it manually and do art plus posters and propaganda
Uh-huh. But
posters.
then, okay.
This way we only have intersection between two uh, categories, which is less than 1 cent.
Mhm. I see. So it was not for me. It was not that clear how to filter down so many results. So maybe.
Yeah. So sometimes people actually need something really peculiar, and only semantic search can deliver it. But if it's massive, like posters or let's say my town, Boris town, Jersey. So
Okay.
yeah, it's 1900 of something with semantic search, but
I
without
see.
semantic search, it would be only maybe 100 of them.
Yeah, because I'm thinking from a user perspective, they need to people, if they're looking images, there is a specific maybe business, they are looking for specific labels or something else. So I'm just curious if it's possible
They
to.
start like usually journey starts like that. They type something here, like silent era. See, there is no tag silent era. It's only tag silent films. So without semantic search or Blu-rays, not Blu-ray, fuzzy elastic search, we would not find anything. But we can find error and access. And it will work without uh, uh, funness and semantic should not. It is not aware and this is still context. So since it's more than about 250, we don't even call semantic search. It's only normal search. But if we want silent era actresses in France, they very unlikely that we have more. It purely shows us 8,000. Why? Because semantic search is to the help. Yep.
I have two more questions.
And here is a noise. Here is a noise. First
Yeah, I
Lady
see.
Melania Trump. Yep.
Second question, do you provide scores, relevancy for every image? For example, this is a user put description. So, for example, first two images maybe more relevant to user search or not. I'm just curious. The question about
we show tag cloud. So if you click on this, you can see general like anonym from HTC or graphic. And when you have a user, actually something is very close to what they are looking for. Let's say l'actrice venait du théâtre français. I don't know how you say it really. But here you go, and you have at least the beginning, like beginning results, which are pretty useful.
Mhm. And second question.
Yeah,
If we will,
I wanted to say about this is visually similar, this is semantically similar, and this is the actually hybrid stuff. That's within those tags, within those massive of images that tag this, we find visually similar. And it can go and go and go forever.
yeah, of
And
course.
it's actually very sticky user interface.
No,
So
interface is great. Yeah, I
we
can.
have users who spend like hours on this. It's a rabbit.
Yeah,
Rabbit.
absolutely. Yeah. Very good. And one more question. Actually, sort. Can they
Huh?
sort? Can they sort results, or it's not?
Well, they only have search, which is like whatever is possible to find, and on the bottom they have sets. So it's not sorting.
Mhm.
Sorting is like in Google. In Google, you cannot direct how it sorts. It just sorts by itself.
I understand.
But here you can actually find very specific sets about. It's only 9 of Guan Xin, whatever this guy, and it's basically what users usually need.
Mhm.
They do video production and they need some images of Guan Han Wing. They don't want Guan Han.
I see. Last question, I promise. If,
Uh-huh.
for example, I have a label text, can we search text inside the images? Just text. For
Yeah,
example, Guan.
like
If I want to search, not Guan, whatever.
how you spell it.
Let's spell something in English.
Yeah.
Clarins. You know that there is a no Fresh. Fresh is a it's a cosmetic company. I want to see all images related to Fresh. So will it search Fresh? Cosmetic, exactly. Yeah, it's a famous cosmetic company.
No, we have nothing about it. I don't know about that, but I know something about. Yeah, I don't know about that. We don't have any public domain fresh cosmetics, but we
Maybe
have
because
fresh.
of
Yeah.
yes, I understand now. Because you don't. It's about source. Okay, of
Yeah,
course.
but we have fresh meat probably.
Meat. Okay. For example, if there is
Fresh meat.
any label spell out.
Fresh meat. See,
Meat?
it's like fresh meat. Something doesn't look like meat. So in this
it was
case,
able to find. Yes, I can see a label. Yes.
yeah, it can actually read somehow.
Yeah,
Sometimes.
but as a user, I really would like to have it on the top. That's why I'm saying relevancy. If there is no label, then if
I
you
think
go,
with more data, once we run actually this leap, that would be much more common sense. Because right now in the meat we have some Afghani people, and the meat only comes here. But once we run bleep, which is about 1 week ahead, and then we add it to the metadata for everyone, for every image, then we would probably have 100 times more pieces of meat here because of it, and less Mars or Moon. So meat is not very popular in our database. I think we have Napoleon Bonaparte
explanation.
mostly. So we have meat, but
I would
is like
search then onion, but anyway.
onion. Okay, that's the onion.
Yes, but it's okay. I'm sorry. Thank you. It was last question. Probably I can see somebody has other question on the chat. Yuri has a question. Thank you very much.
Yeah. Okay, chat question.
Okay, I'm not sure. Can you hear me okay?
Yes.
Okay. So, well, first, actually, I want to ask the last question I asked on the chat. So, do you create an index? Do you index all the archive data?
Well, when they come, we look at the data, and when it comes really badly tagged or labeled, then we add some labels or even descriptions. For search
Oh,
engine
no, but
optimization,
for the search, do you have like a search index so you don't like? Okay, I'm not a search specialist, but the way I understand like search, the way you do search on like a, let's say, large number of.
That's a couple of this software tools. This one VB is a database engine with Elasticsearch connected to it. And Google AI is connected to Elasticsearch.
Okay. So okay, so you're modifying. You sort of have Elasticsearch, and then you build something that integrates with it.
We have actually very similar. If you know, Yandex recently got fucked, or they released something potentially, they got a formula of sorting, which is like a multi-member formula with weights, right? So title weight, keyword weight, alt caption weight, and things like that, or summary or like textual discoveries weight. And we have similar stuff. We weight titles a lot. We have a very good and supervised text. So unlike Google, we weight text a lot. And then with less weight, we weight whatever AI models produce. We run Google labels for the popular images to make them even more findable. They slowly go up. Someone downloads it many times. It becomes more popular. It's self-supported process. And we weight Google labels and our labels similarly. Now we add alternative sentences, descriptions. It's going to be tricky because they can be used in 3 ways. One is just give a weight to the sentence and see if the search request matches it. The second is to add the sentence to the title, which is weighted very heavily, and then sorting will change. I don't know how much, but it will, especially with titles that only consist of gibberish. And the third way is to create completely separate index for the generic terms, like woman looking left, and then deliver those results blended with our current ones. So the average quality of search will increase, but specific search quality will decrease. Or create a separate index as you wish to deliver generic searches like I want to see sunset, and it would be not historical sunset, but stock sunset. But here we have to make decisions. We didn't make it.
Thanks. So right now you're working on copyright-free images. Can you use the same model that you have and let's say work with the private set of images to help, let's say, company wants to search their own images?
Yeah, so we can run 1 million private images weekly in about a week, depending on the number of labels. It's 100 labels, if it's less. If it's like 10,000 labels, if it's longer, maybe months. So whatever set of specific labels the company has relevant to what they do, then we can implement it. We don't have API open, but because we don't have standby machines yet. We will. So you load your labels and then you get the results. But Clip is limited to what it's been trained on. So some really specific stuff, like technical stuff, let's say some technical terms, let's say machine parts, That's not going to be found very well with current clip version, so we probably will have to mix with thousands of the specific data sets that we built the way we did it before for this particular thing. But it's not clone time. It's not very time consuming. We have very, very powerful backend. Yeah. And as for the Leap, it is much faster. Leap, 1 million images will be run. And then again, we're gonna mix it with something, blend something with it. Standby machine, have API, but right now don't have API for that. We have API for retrieval of what we already have, but not for the image recognition. You can see that there is actually user interface for that, but it's not working because the machine that we use for that currently is busy with Leap. We don't have another 20 grand.
Okay. Okay. And the last question was, so you were describing like your next steps, how you want to kind of combine different models. What I was wondering if you have your own sort of labels and you already have working search engine, can you do something that reinforcement learning with human feedback yourself to sort of self-improve your labels?
We actually do that. If you are not upgraded, let me just log down. If you just visitor, then you can go and ask for medium source image, and then you'll be presented with the custom capture, which asks you what it is not first, and you say this is not bomb fuzzy, whatever it is, and then right now it goes to Google because Google has standby API, and it shows what Google found, and then you have Charlotte's onion benefits, like what it is. It's a food, natural food. It's a vegetable. It's not a garlic. It's red onion, and it's not scallion. You do just down. Once you download it for free, it asks you for a money. Asking for a money. There's a gratitude, and people actually give money. You got donation of $50 for instance. For one of the images uploaded, downloaded. But if you look on the backend, now you see this image with Google data and number of votes. Probably I was the first one downloaded, so it's probably going to be votes on Google labels that are verified by me. But since it's verified them similarly, over the time for really popular images, we have a very good human AI look verification reinforcement that we can use in search results, ranking those images higher. As for the labels that we generate, no, we don't do any reinforcement as of now. We actually on a stage when we see so many images that were never found by no one, that we see our current task to improve search to bring them to the surface so people can actually find stuff.
Okay, thank you.
Okay. Boris, thank you. It was 45 minutes. So I'll stop the recording